And now for some revision of reversing the chain rule when we're working with trig functions. Now we've seen this before in our integration unit, but it's something that can be hard to spot. And when we look at a question, we need to remember that if we've got two functions of x multiplied by each other and we're trying to integrate them, then it really needs to fit into one of our standard forms, or we're just not going to be able to integrate it. There's no point thinking about the product rule. That's something we use when we're differentiating, not when we're integrating. So the rule that we need is actually the one that's at the very top of our list of integrals on our reference sheet. It says if we've got f dash x out the front of some function raised to a power, then when we integrate it, we get that same function raised to a slightly higher power, just add one to it, divide by the new power, and add a constant. Now the thing that trips people up is that f dash x is out the front here of our integral, but it doesn't make it into the result. So this is your form of a so-called perfect question. And if we don't quite have a question that's perfect, we can adjust for it and put our fixed factor out the front. So a couple of examples here. We have the integral of sine x. Now this is cos x all raised to the power of 4. So if you prefer to see it written like that, so that it's more familiar and you can see what to do with it, go ahead and rewrite it like that. It's absolutely fine. I'm just going to leave it for now, but I'm thinking in my head of what it looks like when I have it written that way. So ask yourself, do we have the perfect question? If our function of x is cos x, is sine x f dash x? Well, if we differentiate cos x, we actually get minus sine x. So this isn't quite a perfect question, but we can adjust for it by saying we can put a fixed factor out the front, and instead we can integrate this. And again, here is perhaps where you might like to write it like this, so it's looking familiar, like one of these ones. Now, do you have to do this line? Not really. You can do this part in your head and put the fixed factor just into your answer and just think through, well, it's nearly right, it just needed the negative, and I can adjust for that with the negative here. But writing this out in the beginning helps with your understanding, and if you enjoy writing that line, keep writing it if it's helping you get these questions right. So then what we need is just to look at our reference sheet and say the only part that gets in the answer is the actual function of x that was raised to the power, and that was the cos x, and it needs to be raised to a power slightly higher, so instead of 4 it will be 5, and we can write that as cos to the 5x. We need to divide by the new power, which is 5, and then we need to add a constant, and we're done. Now the next one is really similar, except that we're raising sine to an unknown power. It's just the power n, so this is quite a generic sort of question. But again, we need to ask ourselves, if f of x is sine x, is f dash x cos x? Is it a perfect question, or does it need a fixed factor? Well, when we differentiate sine x, we do get cos x, so it is actually perfectly in this form and it's ready to go. So all we need to do is say what was our function of x that's raised to the power, and the answer is that was sine x, and we need to raise it to a slightly higher power, which we can do by just replacing the n with n plus 1. We need to divide by the new power, and we need to add a constant, and we're finished.